Let's take a look at the 2012 multiple choice calculator section. If you're in my classroom, you have access to these answers in Classroom, so you can spend as much time as you need looking at the problems as well as the annotations. And I have annotated, and one of the annotations that I've made is whether or not the question actually uses a calculator or not. So in 76, we're given the graph of an original function. Whoops, let's get rid of that view browsers because that'll keep happening. So in the first one, we have we're given the graph of an original function f. So you got to remember that this is the original function. And for which of the following values of x is the first derivative positive and increasing? So we have to look at two things. We want to know if the first derivative is positive. So if the first derivative is positive, then we know that f original is increasing. So when we look at the graph of f, we can see that f is increasing in this interval, and then f is also increasing beginning here and up to here. So those are two possibilities at this time. And then the next thing says when f prime is increasing. So if f prime is increasing, then f original is concave up, as you can see from the annotations. So the region where f original is concave up would be right in here. And so for increasing and concave up, the value that we're looking at is E. In number 77, we will not need a calculator for this question. F is a function that is continuous on the closed interval, so we're already suspicious of a theorem. F of 2 and f of 10 are given, so we have y value of 10 and a y value of 20. Which of the following is guaranteed? They are invoking the intermediate value theorem. This is a y value theorem that says if our endpoints have a y value from 10 to 20, then every y value, every number between 10 and 20, every y value between 10 and 20 will be included. And you can look at your reference packet to go back and study your theorems, make sure you know the conditions and the promises. So this says f of x, there is a y value of 13 at least once between 2 and 4. There's a y value of 13. Well, 13 is between 10 and 20. I mean, you can read the rest of them, but you got sometimes if you know it's the answer and it's true, there's really no reason to move on, and you might misread another distractor and end up choosing that instead of the correct answer. Again, if you're in my class, you can study the annotations in Google Classroom, because I have taken and broken down what every letter is saying, so that you can understand even what the distractor is trying to say. In number 78, you will need a calculator. So the first thing you would want to do is put e to the tangent x minus 2 in your calculator as y1, as you can see right here. And the question is asking, this given function crosses, they're telling us it crosses at one point. What is the slope of the graph at that point? So the first thing we have to figure out is, where does the given graph cross the x-axis? So on your calculator, then you're going to want to put in y equal to, let's turn the calculator on first, that'll be helpful, y equal to e raised to the tangent of x. I don't think I hit the raised to. Let's delete. Oh, yes, I did. Sorry about that. Tangent of x. And we're going to close the parentheses. Be really careful with parentheses. They can really mess you up. Minus 2. And I'm going to put in y number 2. 0, and I'm going to do a Zoom 6 window because I can see the answers. I'm going to be within a standard viewing window. I could have done that even smaller. Well, they tell me to go from 0 to 1, so I better do that because there's so many crosses. So 0, or x-intercepts, 0 to 1, and I'm going to change my counter to be by 0.1. That just is spreading the horizontal axis out a bit. Much better. Okay, so the graph e to the tangent x minus 2 has crossed the x-axis, so I'm going to do an intersect, so that's second calc or second trace number 5. Enter, enter, enter. And remember, you need to store that value, so while this is on the screen, you're going to second quit, and you're going to store, and you're going to put it generally in alpha A. You can put it in any letter that you want, and you can see that that number has now been stored. And then what they want us to do is to find the slope of the graph at this point. So on the home screen, I'm going to tell the calculator, I'd like for you to find the derivative, math number 8, and then type in however it goes into your calculator. The function that we want to find the derivative of on my calculator is in y1. If you have shortcuts on your calculator, please make sure you are familiar with them. It's going to be really important that you are comfortable and proficient with using your calculator. In terms of x at alpha A, close the parenthesis, and again, if you have a newer model calculator, it's kind of intuitive of what you would type in. And that's going to give me my 2.961, and that is D. All right, so let's go back. Let me get rid of my calculator. There we go. Number 79, there is not a calculator needed. We have a particle that's moving along the x-axis, so we have a particle that's just kind of going back and forth along a horizontal line. The velocity of the particle at time t equal to t is given by v of t, and the acceleration is given by a of t. Which of the following gives the average velocity? If you're in my class, you know that we like to insert the word average value of velocity. So that gives away what we're actually supposed to be doing here. So average velocity, as I just said, is average value of velocity. So we're going to take our average value formula, 1 over b minus a from a to b of v of t dt. So in this case, that would be 1 over b minus a would be 1/8. Low bound is 0. High bound is 8. V of t dt. And that's the expression for the average value of the velocity. Number 80, we do not need a calculator. They've given us a graph of the first derivative of f. The graph of f prime, the derivative of the function f is shown below. Which of the following statements must be true? Be careful that you pick true and that you don't pick false. So the first statement says, f original has a relative minimum. That means the first derivative would change from negative to positive at -3. So 1, 2, 3. So right here, the first derivative graph is changing from negative to positive, so there is a local minimum on f original. Number 2, the graph of f has a point of inflection at x equal to -2. So at x equal to -2, we are right here. Now be careful, because it asks, does the original function f have a point of inflection? Well, according to the All About Me sheet, the original function has a point of inflection when the first derivative changes from increase to decrease or decrease to increase, which is the same thing as saying have a local max or a local min. It's really important that you study and know everything there is to know about the All About Me sheet. So this is a false statement. So we can get rid of number 2. And number 3, the graph of f original is concave down. Remember, this is the graph of the first derivative, so for the first derivative must be decreasing in order for the original function to be concave down. So we go from 0 to 4, so 0 is here, and 4 is here. And on that interval, let's get a highlighter, on that interval, the graph is decreasing, the entire time. So that is a true statement. So we will select E, 1 and 3. All About Me sheet. Really, 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 really important. Most of your tests will be connected in some way to the All About Me sheet. In 81, we do need a calculator. Water is pumped into a tank at the rate of. So first thing you want to pay attention to is that R of T is a rate, and it's measured in gallons per minute. T is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, so we already know that we have an initial condition. I don't want that bold or underlined. We have an initial condition that at time 0, there are 800 gallons of water. So that's important to be aware of. How much water to the nearest gallon is in the tank after 20 minutes? So if we're going to consider water in the tank, we have to take into account that there were 800 gallons of the water to begin with. So this is an initial condition problem that includes 800 gallons, starting at time 0, stopping 20 minutes later, accumulating the area under the rate, and if you take that off of your calculator, and I guess I'll do that, sure, why not? You can skip over it if you don't need to see it. So since there's no need for me to put this function into y number 1, I'm only going to use it one time. So I would do a math number 9, and the function is 30 times 1 minus e raised to the negative 0.16. Be careful with your typing. One little parenthesis, one little mistype, and it's over. Okay, so that's the function. And from 0 to 20, close. And I realize I did not put my 800 in front. I don't really have to, but I want to. So I'm going to do a second insert of 800 plus. And then enter. You could have added up. I shouldn't. I knew that was going to happen when I tried to. Let's see. Where do I have an extra or a parenthesis that didn't get closed? 1 minus e. Okay, right there. See that parenthesis right there? Notice what I did also. I didn't quit. I did go to. I need to. It's telling me there's a parenthesis that's unmatched. So I can see right there that this parenthesis did not get matched right back in here. So I'm going to have to come back in and do a second insert parenthesis, and I should be okay. Nope. Go to enter. 30. So let's start matching parentheses. Oh, I forgot to put it in terms of x now. Well, I was going to say thank you, but I just told myself, so I was hoping one of you would be able to tell me. All right. And now close. All right. Quick prayer. Yep. 1200.143. And it's actually good for you to see me struggling with the calculator and the parentheses and the typing. And that's why I keep warning you to really practice with your calculator because these kinds of things happen. All right, let's go to the next page. Number 82. We're given a first derivative of f. And it is a radical and x cubed minus 3x. F, where questions about f original, a local maximum. Local maximum is where the first derivative changes from positive to negative. So all I want to do is take a look at the given function, and I want to figure out where the original function changes from positive to negative using my calculator. Again, if you don't need this and you got it right, that's great, but some folks may need it, so I'm going to show it. All right, so when I do this, I'm not going to do the radical. I'm going to do this to the 1/2 power. So I'm just going to put in my parentheses, x raised to the 4th plus 1, close, raised to the 0.5. So that's x to the 4th plus 1 to the 1/2 power square root of plus x raised to the 3rd power minus 3x, and I already have, let's see, do I have that typed in correctly? I already have y2 equal to 0, so I'm going to do a Zoom 6 window, which is my standard viewing window. And it's not going to be at this point of intersection because the first derivative changes from negative to positive. Here, changes from positive to negative. So I'm going to do a second calc or a second trace. Number 5, remember that the calculator will find the point of intersection that's closest to, and I get 0.350, which is the answer that I selected. Okay, let's take a look at number 83. In number 83, there's not a calculator needed. The graph above gives velocity. So we're talking about a velocity function, feet per second from 0 to 8. Of the following, which is the best estimate of the distance traveled by the car from t equal to 0 until the car comes to a complete stop? All right, so we're going from, let me make sure I read everything. We're going from 0 to 8. And so we're accumulating area. So in my opinion, the best and easiest way is to count blocks in this case. But remember, when we talked about counting blocks to find that area, we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, count all the whole blocks. 10, 11, 12. Make sure you dot them so you don't lose any. 13, 14, and then you can start piecing them together. But the big idea is remembering that one block of area is 1 by 10, so one block is equal to 10 units of area. So when I counted these blocks carefully, and I think I counted them fairly carefully, I said there were about 21 blocks, and 21 times 10 is about 210. So hopefully you counted carefully. The only two that are close to that are 260 and 180, and I'm thinking that those are far enough off that you would get the 210 that we're closest to. And that's really all I have to say about that. Number 84, do you need a calculator? You do. So we're on the interval from negative 1.5 to 5, so you got to keep that in mind, with the given first derivative here. Which of the following are intervals where f original is concave down? So for f original to be concave down means that the first derivative is decreasing. So you don't have to find the second derivative. You can make the calculator do the second derivative for you, but you don't really have to. So in this case, I'm simply going to put in y1, clear that out, e raised to the x to the 4th minus 2x squared plus 1, close that parenthesis, minus 2. And they told me to go from, I'm going to do my window from negative 1.5 to positive 1.5. And again, since it's a small window, I'm going to change my scale to tenths instead of ones. That just spreads the graph out. I'm looking for when this graph that I'm producing is decreasing. Okay, so I can see, and when I look at my answers, I can see that there are two regions in which the graph is decreasing. Now it looks like the decrease starts at 0, but what I'm going to do is I'm going to make the calculator, just to be on the safe side, I'm going to, what am I going to do? Yeah, I can see that the graph is decreasing starting at negative 1.5. So it's already going to be between D and E. And then right down here, there's the first derivative graph starts to increase. So I need to know what that local minimum is. So I'm going to do a second calc I'm going to select number 3 for minimum. I'm going to left bound that thing. In other words, the cursor has to be on the left of what I think the minimum is. Enter. And then on the right of what I think the minimum is. And then enter, enter. And even though it's negative 0.9999999, it's really trying to tell me that that's the x value of -1. So just based on that, I can select letter D. 85. No calculators needed because they're giving me the graph of f prime, or the first derivative. The first derivative is given of f, shown on the figure above. The function has a local maximum at. So we're looking for a local maximum. This is first derivative, so we're looking for the first derivative to change from positive to negative, and the first derivative changes from positive to negative at x equal to 1. All about me sheet, all about me sheet, all about me sheet. Notice you keep hearing that in the videos because most of the test is connected to the all about me sheet. Number 86, no calculator is needed. So we have a first derivative that is positive. So that means that f original is increasing all the time. So so that's important to remember. And the accumulated area from 4 to 7 is 0. So if the accumulated area from 4 to 7 is 0, then there has to be negative area and positive area that offset each other. In other words, the graph from 4 to 7, the graph has to change either from negative to positive or positive to negative. So which of the following could be the table of values? All right, so since the integral from 4 to 7, I'm reading down here, since the integral from 4 to 7 is 0, f is both negative and positive. So that eliminates A, D, and E, because we only have negatives and 0. D is just zeros, and E is all positives. All right, so now we're stuck with between B and C. So for C, the slope from 5 to 7, the slope, if you do change in y over change in x, is negative, so B has to be the answer. So if you do the change in y, so 3 minus 6 is -3. 7 minus 5 is 2. -3 over 2 would mean that the first derivative is negative, but we said that the first derivative is positive all the time. So it has to be B. Number 87, no calculator needed. We have the graph this time of the second derivative. So this is the second derivative, not the first. I'm getting better at this using a mouse or laptop to write. You don't care. The graph of the second derivative of f is shown above from -2 to 4. What are the intervals of the graph of f original concave down? So for f original to be concave down, we're looking for where the second derivative is negative. Now I'm getting bold. So the second derivative graph is negative in this region, and the second derivative graph is negative, in this region right here. And so we're just going to select those intervals. All about me sheet, all about me sheet, all about me sheet. Know the all about me sheet. 88. Calculator is needed, but just for calculations. This one's really about reading. A person whose height is 6 feet is walking away from the base of a street light along a path at a rate of 4 feet per second. If the height of the street light is 15 feet, what is the rate at which the person's shadow is lengthening? So right over here is the picture that's given. So that's the person's shadow. This is the distance between the person and the lamp. And then the lamp itself is 15 feet high, and light is shining down so that we're going to form, whoa, I almost had it. So we're going to form, eventually. Anyway, you get the idea. You can see over here on the left-hand side, a right triangle. So here is my diagram of what's going on. And with the similar triangle situation, the key is making sure that you label with your variables correctly. So we have two things that we don't know. We don't know the length of the person's shadow. I made it Y. And since the person is moving away from the lamp, that is a variable as well, and I made that X in my work. The lamp is 15 feet tall, and the person is 6 feet tall. So what I have here is a series of similar triangles, a big triangle and a little triangle. So that means the corresponding sides are proportional. So when I take the 15 and the 6, because they're corresponding sides, and I set up that ratio, which I've done right over here, is equal to the entire length of the big triangle. So that would be X plus Y, and that's where I got the X plus Y. And you can do this, you just have to persevere, over the little side of the triangle, which is Y, and it corresponds. So that's my beginning point. They told me that the person is walking away from the lamp at a rate of 4 feet per second, so that's the dx dt. And I'm trying to find the rate at which the shadow is lengthening, which is dy dt. So I'm going to cross multiply first to make my life easy, because I really don't want to do the quotient rule. And then when I do, I'm going to stop there and I'm going to do my, I combine like terms, so I move the 6y to the left side by subtracting. Then I took the derivative of both sides, chain rule, implicit differentiation, so I had a dy dt and a dx dt. I substituted the numbers that I know, and I used my calculator to calculate my number. So it's not a real hard problem, and I would encourage you strongly to go back and set it up, and even though you've heard the explanation, go back and do the whole thing by yourself. Number 90, we do not need a calculator. We have a function. We have an inside and an outside function here, and we're trying to find or evaluate or figure out what would happen for our definite integral. In other words, this integral is equivalent to what integrals? So we're going to need a u substitution because we have, an inside function of 2x. So when we're trying to integrate inside-outside function, a composition of functions, we let u equal to the inside function. And then I take the derivative of both sides. When I look at my original integral, I don't have a 1/2 up here anywhere, so I'm going to divide both sides by 2. So now I'm going to make my replacement. My 1/2 is going to be out front, and then my substitution of the u, they used a t, is going to be here. And the main thing to remember that will mess you up is remembering to change the x bounds into u bounds, or in their work they did t bounds, whatever, it doesn't really matter. The variable is trivial. But you have to substitute your original x values, in here to change into u bounds. And you can see the answer. Number 91, let f be a polynomial function. So that, first of all, if we have a polynomial function, it's continuous and differentiable. Values of f prime, first derivative, are given in the table above. Which of the following must be true from -2 to 6? The graph of f is concave up. Well, you can see down here below, I've typed up exactly why the things, each distractor can't be true. So in letter A, for f to be true, for f to be concave up, f prime would have to be increasing at all times on the interval. This is not true, because if you look at the values in the table, 3, 1, that's already a decrease, so that's over. B, the graph of f has at least 2 inflection points. That means the concavity changes at least twice. That means that first derivative changes from increase to decrease or decrease to increase at least twice. Now the polynomial piece is important because it tells us that the original function is continuous and differentiable. So follow the f prime of x tables in the value. The value of f decreases, then increases, then decreases again, indicating that f prime has at least one local max and one local minimum. So this has to be true. And then I'll let you read the other distractors and look at the explanation as to why they cannot be true. And number 92, let R be the region in the first quadrant. Again, reading, we're only talking about the first quadrant, bounded by the graph of y equal to x squared and the graph of the square root of x. Yes, you could graph these by hand, but this is a calculator part. R is the base of a solid whose cross sections are perpendicular to the x-axis. R squares. What is the volume of the solid? So remember, you begin with geometry by writing down the formula for the area of, in this case, a square, which is s squared. Then when you look at your calculator, and so you would have y equal to, turn the calculator on, y equal to x, let's clear that out, x squared, and for y2, square root of x, zoom 6, a standard viewing window. And I'm going to do the zoom box just to remind you how to do that. So for a zoom box, you're going to press zoom. You're going to select number 1. And at the origin, blinking really tiny is a little plus sign. So I'm going to move that, use my arrow to move up past the region I want to capture. I'm going to move a little bit to the left. I'm going to press enter, and then it turns into a tiny little box. I'm going to use the down arrow to open my box below, a little bit below the x-axis, and then beyond the point of intersection. And then I'm going to press enter, and that's going to blow that region up for me. And so now I can see that the length of a slice would be from the curve that's on top, which is the square root of x, to the curve that's on bottom, which is x squared. So the length of the segment is square root of x minus x squared, which I've indicated here. And then because we have a square, the formula for area of a square is a side squared, so we're going to quantity square that, and then we're going to go from 0 to, that should be a 1 because that's where those two curves intersect, which you can get off your calculator. And then I'm going to let the calculator do the integration for me, and then I'm going to select my answer. So 2012 multiple choice calculator section.